So is it possible for us to calculate the electric field from electric potential? And the answer is yes. The only thing we have to do is consider something called the gradient operator and partial derivatives. So if you haven't learned that yet in Math 119, you will be fairly shortly. So I want to first start off by saying we know that dV, the differential potential, is equal to negative E dotted with dl. In Cartesian coordinates, we can write this as follows. We know that E is going to be equal to the component of E in the x direction, some component of E in the y direction, some component of E in the z direction. We also know that dl can be broken down into its components too, so a certain distance traveled in the x direction, y direction, and z direction. So putting those two together, if we take the dot product of these two vectors, in which case we have EX, EY, and EZ, and then we have DX, DY, DZ, we know that dV can be written as negative EX dx plus EY dy plus EZ dz. Because the unit vectors become a value of 1. The other thing we want to take note of is how to calculate these values. So if we split this up, we can actually define this electric field in 3 different ways. We can say EX is equal to the partial derivative of V with respect to X. We can say that EY is equal to the partial derivative of V with respect to Y, and we can say that EZ is equal to the negative partial derivative of V with respect to Z. But the gradient operator, or the del operator, is given as del di over di x, x hat, plus di over di y, y hat, plus di over di z, z hat. Which means we can simplify and condense the equations above. So basically the partial derivatives, we can now say E is equal to negative So I'm just combining all 3 of these together. So I have E equal to essentially all these partial derivatives of potential with respect to x, y, and z, but we know that the del operator is this, and we can simplify that even further and say that E simply equal to negative del V. So then we should probably ask ourselves, does this even make sense? So when I look at this, it tells me that the force or the field is going to be dependent on the slope or derivative of the potential. That does make sense. The force in each direction should also depend on how the potential changes in each direction. This makes sense too. And then if the partial derivative of potential is greater than 0, so basically when a derivative is greater than 0, and that means the slope is positive, then that means we're going to go up the hill and the electric field is going to point in the opposite direction. So all of this makes sense, and we can use this del operator, or basically a whole bunch of partial derivatives, to calculate the total electric field as well as a vector.